So the Laplace random variable model is summarized in appendix A. Let b equal to 2 and calculate the value of p minus 0.37x less than or equal to 0.28. If you have this, it means we need to write it like this. That is capital Fx 0.28, this one x2, minus capital Fx x1, which is this. Now, for Laplace, the expression for the CDF is something like this. Greater than 0, this expression. Less than 0, this expression. So for greater than, here we have x value positive greater than 0. Therefore, I should use this expression. 1 minus half of exponential b is given to us minus 2. The value of x is 0.28. Using that, you find out the value. Then the fx of minus 0.37 is found by using this. That is half of exponential b is 2, x is, minus 0.37. So using that, you find this value. Then subtract one from the other, then you should be able to get 0.4758, right? Using the calculator, you can do all that and you'll get 0.4758. Then the second is the Cauchy's random variable. Again, some range of probabilities, what you call, is to be found. And the again, expression is just the same, fx of 7.6 minus fx of minus 5.3. Now, in the Cauchy's random variable, this is there. You need not remember all this. Please be sure that you need not remember. The table should be supplied to you. Statistical table should be supplied to you where this expression is present. Okay. Otherwise, better have the appendix A, Xerox with you. Take the seal, my seal, and keep it with you. Okay, take the seal of the HOD and keep it with you, the what you call appendix A from the book, okay, which I'll be sending to you also. Fine. So now, what you call 7.6, here this range is for both positive and negative, so you can just substitute 7.6 or minus 5.3 either way and find both the fx values, subtract them, and we'll get the value. Okay. So this is tan inverse. This is tan inverse of x by a. Then you have the Erlang random variable model. Same thing again. Only that Erlang, the formula is different. E to the power of minus lambda x, sigma j equal to k, j is equal to 0 to k minus 1, lambda x to the power j divided by j factorial. So this will be a little, dragging because of the, formula here. E also you have, summation also you have. Okay, for all that 4.6 as well as 1.3 for what you call, both are positive here. Okay, both are positive here. So therefore, you need to consider this formula only. If one is negative, then for that it will be 0, right? If it's given minus 1.3, for that it will be 0. So you need not bother. Only you need to find for this. But here both are positive, hence we need to use the same formula for that. Then we have the 14th question as PDF is described by c into x minus 1 for all values of x between 6 to 10, 6 and 10, and 0 otherwise. Find the value that c must have and evaluate p of x greater than 8.0. So let us see this. So same thing I have repeated here. Same thing I have repeated here. So I am trying to plot the PDF over here, small fxx, right? So what does he say? It is c into x minus 6. When x is equal to 6, the value of this will become 0. Okay, it cannot have, this fxx cannot have negative values. It's not possible to have probability which is negative. So we don't bother about 0 to 6. Whereas after 6, we'll see, because we are given also that between 6 to 10, between 6 to 10 is 6 and 10 is given. So at 6, the value is, 6 minus 6 will be 0. So it will be 0. At 7, it will be 7 minus 6 will be just c. At 8, it will be 8 minus 6 will be 2 into c. At 9, it will be 9 minus 6, that is 3 into C. At 10, it is C into 10 minus 6, that is 4C. So all that is written over here. C, 2C, 3C, 4C. At 6, 7, 8, 9, 10. Okay, at 6 it will be 0. At all other values, that is 7, 8, 9, 10, it will be C, 2C, 3C, and 4C. Now, this is a triangular function. Area under the triangle of the probability density function will give us a value which is equal to 1. Okay, which is equal to 1. So between 0 to 6, fx dx equal to 1. You can write the expression for this and integrate also. But we know the formula for the triangle: half into base into height. So base is 6 to 10, that is 4. Height is 4c. So half into base into height is, half into 4 into 4c equal to 1. So this will become 8, and therefore c will be 1 by 8. C will be 1 by 8. So we can find the value of c like this. Now, probability for x greater than 8.0, that means integral 8 to 10 fxx dx. Now this is area under the curve, same area under the curve. Okay, between 8 to 10, between 8 to 10 of this graph. So what do we have between 8 to 10? If you see this, this is a trapezium. Between 8 to 10, what you have is a trapezoid or trapezium, whatever you call it. Trapezoid or trapezium. So for this, what is the formula? Half into base multiplied by height 1 plus height 2, height 1 plus height 2, either way. Okay. So height here is 2c, height here is 4c. Height here is 2c, height here is 4c. So add that, that will become 6c. Then you will have 10 minus 8, that will cancel, and we will get 6c. C is 1 by 8, therefore this will become 3 by 4, that will give us 0.75. Then we can come to a similar example in 15, question number 15, if you see there. Okay, this is 15. So in the 15, what do we have? C, y minus 3 for all values between 6 to 10. Find for p of y greater than 7.0. Okay, y greater than 7.0. So between 6 to 10, it is c into y minus 3. So at 6, it will be 3c. At 7, it will be 4c. At 8, it will be 5c. At 9, it will be 6c. At 10, it will be 10 minus 3 will be 7c. So area under this total thing will be equal to 1. Okay, area under this will be equal to 1. So again, this is a trapezoid. So for that, you can try to write half into base, that is 10 minus 6 into 7c plus 3c equal to 1. That will give us, 10c is equal to half, that is c is equal to 1 by 20. Okay, c is equal to 1 by 20. Then for y greater than 7.0, area from 7 to 10. Area from 7 to 10. At 7, you have 4c. At 10, you have 7c as the height. So height to two heights should be added, 7c and 4c. And here it will be, base is 10 minus 7, that will be 3. So we'll get the value here, half into 10 minus 7 into 11c, and that will give us the value of c also should be substituted. 3 by 2 into 11 into 1 by 20, that will give us 33 by 40. 33 by 40. Similarly, you can find 17 also. Okay, 17 also you can try to solve and see what is there. So here in the 17c, what is given to us is FUU equal to C exponential minus U by 2. So again, PDF is given. C is to be found. C is to be found. The value of F small PDF is only existing between 0 to U to 1. So therefore, again, minus infinity to infinity, FUU, small FUU is equal to 1. So 0 to 1, because it exists only between 0 to 1. This value is there, so you need to integrate this. If you integrate this, the integration of this will be exponential minus u by 2 divided by minus half. If you are integrating, you will get in the denominator minus half. That will become, you take it to the numerator, that will become minus 2c. You can substitute the values there. Okay, 1 and 0. So you will get exponential of minus half minus exponential of 0. This value will be 0.60653. This value will be 1, and hence we will get this as C equal to 1 by 0.787, that is 1.2707. Once having found that, then you need to write the expression for f of u minus 5.5, what you call value for fu 0.5. So that will be 0 to 0.5 fuu, and that is minus 2c into exponential of minus 1 by 4. This will become, here it will be the value, the expression is this. So therefore, if you substitute that 0.5, you will get again the value which is minus 1 by 4, and that turns out to be some quantity there and minus of exponential 0. And this quantity will be, whatever, minus 0.2212, and this quantity will be 1.2707 of minus 2, and hence we'll get 0.5626. C is 1.2707. This quantity is minus 0.2212, and you'll get 0.5622. Okay, this is the final solution. So if you have any doubts, you can ask.